Alrighty, welcome back. This is the last section we are going to be doing from Chapter 8, and then we'll be moving on to Chapter 9. For the most part, this is a repeat of 8.3, except for it is going to be the application-based problems with trig. So we are going to name this angles of elevation and depression. All right, so we already learned about our trig ratios. Our trig ratios are sine, cosine, and tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We talked about using the trig ratios, and we talked about using inverse trig. Inverse trig is used when you are trying to figure out the angle measure, and the actual trig ratios are used when you are trying to determine what a side length is. So here we go. And all this is going to be is just applications to trig. We use these terms angle of elevation and angle of depression, and all that is talking about the line of sight when you are looking up or you are looking down. So an angle of elevation is an angle created between the line of sight and a horizontal line. When looking up. All right, and then angle of depression is just going to be the same exact thing. Rather than writing that whole entire thing out, I'm just going to do this. An angle created between the line of sight and a horizontal line when looking down. Let me go ahead and show you an example of this. If we had a person standing here and he was looking at something up in the sky, there's something called the line of sight, which is this, and then we have a horizontal line. Here is a horizontal line. The angle between those two things, this right here, is called the angle of elevation. Now, angle of depression would be if you had something that was higher than another thing. You would have a line of sight, and then you would have a horizontal line, and this right here would be your angle of depression. Now, it's very, very, very tempting to think that this is the angle of depression, but that is not the angle of depression because it does not say the angle between the line of sight and a vertical line. It says the angle between the line of sight and a horizontal line. I'm telling you, this is the one thing that you are going to possibly mess up on when you're doing these problems. Be very, very careful. It's going to be very tempting to think the angle is right here, but actually, if you have an angle of depression, something is looking down, you have the line of sight, which is easy, and then you have to have a horizontal line. Even if they tell you what the height is, and you're going to want to go over and write that down with the length there, you can always go over and put that same number over here, but just understand you have to have a horizontal line and the line of sight, and that is the angle of depression. Be very careful. I give the same warning every single year that I teach this, but it usually becomes the thing that people struggle with. So when we're looking at this, and we're trying to figure out if it's an angle of elevation, angle of depression, or neither, I'm going to throw that in there, or neither, you have to ask yourself, is it between the line of sight and a horizontal line looking up, looking down, or is it neither one of those? So here the bird is looking down at the guy. Line of sight, horizontal line, that right there would be the angle of depression because it's looking down. Now here is the guy looking up at the bird. Line of sight, horizontal line, so that one would be the angle of elevation because he's looking up. Now, how about this one? If the man is looking down at a point at the base of the mountain, line of sight right here, horizontal line, would that be an angle of depression or elevation? That one would be depression. And right here, looking up at the man, line of sight, horizontal line, that would be your angle of elevation. All right, take a look at this right here. If we had a man, actually, let me go back. If we had a man floating in the air somehow, and he was looking down at something. Here was a horizontal line, here was the line of sight, and here was a vertical line. This angle right here, would this be an angle of elevation, depression, or neither? Well, this is the line of sight, and here is a horizontal line. This would be your angle of depression. This is nothing, okay? You could go over and say that these two together make 90 degrees and use this angle to figure out what the angle of depression is, but this one is not the angle of depression. One thing that's worth noting, though, the angle of depression looking down is going to be the same as the angle of elevation for that other thing looking up, and that is because of the alternate interior angles theorem. All right, let's keep moving. So now you guys know what an angle of elevation is and an angle of depression. Sometimes you have problems like this, which are pretty straightforward and not complex at all. It's basically a triangle, and you're trying to solve for a missing length. Since I don't want this to be a super, super long section, let's go ahead and just solve for x. Let's say we were trying to figure out what x is. Well, just like in 8.3, we would say what two sides are we working with? That one would be the opposite and the hypotenuse. You have to ask yourself what trig ratio uses the opposite and hypotenuse, and that one would be, if we look at SOHCAHTOA, SOHCAHTOA, which one has opposite and hypotenuse? Opposite and hypotenuse is sine, and then we just have the problem. Sine of 35 degrees equals opposite, which is x, over hypotenuse, which is 20. And then we can go over and just solve for this. Remember I told you the trick is just multiply by whatever's in the denominator. So multiply by 20 and multiply by 20, and this turns out to just be a one-step equation. We can solve that. Make sure your calculator is in degree mode. And let me check if my calculator is in degree mode. Second trig. Give me 1 second. 20 times sine of 35, and that gives me 11.5 approximately feet. Now on your homework, what I'm asking for you guys to do is leave the units out. I know Heinz would be pretty ticked off about this, but just because the Google Forms is kind of testy when it comes to how the answers are given, just give it as just a number rounded to the 10th each time. So you would give an answer as 11.5, not 11.5 feet. So that's just a pretty basic problem where really it's just a triangle, but they go over and draw a picture to make it look like it's a real world problem. This is much, much more like a problem where we're talking about angle of elevation and depression, actually. So it says, suppose you stand at 53 feet from a wind turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye height is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? So when you're making these pictures, don't get too crazy. Just make a basic guy, make a little wind turbine or whatever the heck it is. I'm not even going to make the little fins on it. Now it says angle of elevation, so I need to show line of sight and a horizontal line. Notice the triangle is kind of hovering in the air. And then they say the eye height is 5.5 feet. We'll have to deal with that in just a little bit. Tells us that you are 53 feet from the wind turbine. We're trying to figure out what the height is. This only tells us part of the height, and then we'll deal with the eye height in just a second. And it says that the angle of elevation is 56.5 degrees. So at this point, what you need to do is solve for x, and then remember that you still have the 5.5 feet that this triangle is hovering up in the air above. So the two sides that we're working with are opposite and hypotenuse, or no, opposite and adjacent. Opposite and adjacent using SOHCAHTOA, that is going to be tangent. A lot of times these problems use tangent. Probably remember using tangent when you did the rocket day, if you guys did that with Mr. Hines. So tangent of 56.5 degrees equals x over 53, because it is opposite over hypotenuse. We will then solve 53 and 53. Pop that in your calculator. 53 times tangent of 56.5 degrees. Enter, and that gives you x equals approximately 80.1 feet. Now that is just what this part is. You got to remember that you still have the eye height, because the triangle was floating up in the air, because the guy wasn't laying on the ground with his eye level on the ground. His eye level was up 5.5 feet. So we need to, in this case, add 5.5 feet, and that gives us 80.6 feet. Now, really, I would prefer that you guys don't round until the very, very end. So what I should have done was gotten my x, left it in my calculator, added 5.5, and then rounded once. If I did that, I would have gotten the same answer, though, 80.6 in this case. So notice, as I said, sometimes the triangle is going to be hovering up in the air. Let's go ahead and look at some more problems. The rest of them are just application problems. Here we go. The next one says, to approach a runway 17 at Panoka City Airport in Oklahoma, the pilot must begin a 3% descent starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airplane? This is kind of a complex problem. So when we draw this out, we know we have, that's the ground level, and then here's sea level. The difference between the actual place in Oklahoma and sea level is 1,007 feet. Next, you have an airplane. Here's the airplane. Here is the runway. It says you have an angle of depression, so horizontal line, line of sight, and it says that it is coming down at an angle of 3 degrees. Okay. Now it tells us that this whole entire thing, the height of the plane, is actually 2,714 feet above sea level. Now really, this is what we care about. So we need to figure out what is that right there. Any ideas? If you said subtract, you are correct. So it's 2714 minus 1007. And that tells us that this right here is 1,707 feet. Okay. And then it says to approach, let's see what we're solving for. To the nearest tenth of a mile, how far from the runway is the airplane? Now this is kind of confusing because we don't know if they're talking horizontal distance from the runway or if they're talking how much does the plane have to pass through the air. Let's go ahead and pretend like they're talking about horizontal distance. So we're really trying to figure out what that is. Now notice our triangle is up here. So all we have to do is if here's where an x is, you can always put the x up there as well. Make sure you remember, this is not the angle of depression. Make sure you didn't go over and say, oh, this is 1,707 feet, angle of depression is 3, and you put a 3 in there. That would have been incorrect. So now let's go ahead and solve this. If I wanted to redraw it, it would look something like this. 1707, we want to solve for that length, and this is 3. What sides am I working with? Opposite and adjacent. What trig ratio uses opposite and adjacent? Tangent. Tangent of 3 degrees equals opposite over adjacent. At this point, we have to multiply by x and divide by tan of 3. Divide by tan of 3. So let's see what we get then. My calculator is really funky. It's like a super basic one I have here at home. So it's really hard for me to punch this stuff in. Divided by second tangent. Hopefully this works. Tangent of 3 degrees. I get 32,571.5 feet. And if they wanted to know miles, you have to know that there are 5,280 feet in a mile. So you take that and divide by 5,280, and you would end up with, says to the nearest tenth of a mile, you would end up with 6.2 miles. I want to remind you, be very careful. The angle of depression is not right there. It's between the horizontal line and the line of sight. Let's go ahead and do another one. I actually want you guys to try this one. Go ahead and try this problem and try to get your correct answer. All right, it says you cite a rock climber at an angle of elevation. Here's the rock climber up here. Angle of elevation of 32 degrees. It says your eye height is 6 feet high. So this is also 6 feet high. It says you are 1,000 feet from the base of the cliff. Approximately, what is the approximate height of the rock climber from the ground? So we are going to solve for this, and then you have to remember the fact that we still have to add the 6 feet there. So looking at this, what sides am I working with? Opposite and hypotenuse. Opposite and hypotenuse is tangent, if you look at SOHCAHTOA. So tangent of 32 degrees equals opposite over hypotenuse. At this point, we would multiply by 1,000 and multiply by 1,000 and find out what we get. 1,000 times tangent of 32 degrees. That gives us 624.8, but I'm going to now add the 6 feet to that before I round. So once we got our answer and we added 6 to it, you should have gotten 630.9 feet. Once again, you got something 6 less than that for x, but then you have to remember the triangle is floating up in the air. Right. Next one. It says a search and rescue helicopter is hovering 30 feet above the water. Here's the helicopter. Here's the water. A diver spots a man drowning at an angle of depression of 34 degrees. Line of sight, horizontal line. Remember, this is the angle of depression, not this is going to be the 34 degrees, not over here, no matter how tempting it is. Why is it going to be tempting? Because you would have probably wanted to label this as 30 feet. But even if you do that, you could still put the 30 feet over here as well. It says, how far will he have to swim when he jumps in the water? So if he jumps down into the water and swims across, this is the distance he's going to go, which is the same as that distance right there. So I give a problem just like this one in the homework, except for I ask for something else, which makes it so that you're solving for a different side. On this one, we have the opposite and we have the adjacent. So which side or what trig ratio am I going to be using? Sine, cosine, or tangent? SOHCAHTOA. Which one has opposite and adjacent? Tangent. So we'd say tangent of 34 equals opposite, which is 30, over adjacent, which is x. And remember, you always multiply by what's in the denominator. And in this case, it's a two-step equation. 30 divided by tangent of second trig tangent of 34. That gives us 44.5 feet approximately. So like I said, the problem in your homework is a lot like this, but just slightly different. Now I want to go over and do a problem that I realized is in your homework, but not in your notes. So let's go ahead and do this. Let's say you had a 40-foot ladder, leaning up against a building. The base of the ladder was 9 feet from the wall. What is the angle between the ladder and the ground? So let's go ahead and draw this. Here is your wall. You have a 40-foot ladder leaning up against it. The base is 9 feet from the wall. That's 90 degrees. And we want to know what this angle is between the ground and the ladder. So this is where we're going to be using inverse trig. So what I want you guys to do is, now that you've set this up, I want you to solve for x. What is x? You guys should have seen that you have adjacent and you have the hypotenuse. So adjacent and hypotenuse, if we look at SOHCAHTOA, adjacent and hypotenuse is cosine. So you do cosine of x equals adjacent over hypotenuse. Now we do inverse cosine to get rid of that. We do inverse cosine on this side because we have to. So when we put inverse cosine of 9 over 40, let's see what we get. Inverse cosine of 9 divided by 40, we end up with approximately 70, let's say we were rounding to the nearest tenth of a degree. You would get, well, you end up having 76.997. If you're trying to round to the tenth, you look one before. So this one would give you, that rounds that up, and that one rounds that up. So rounding to the tenth is actually going to be 77 degrees. So this is an example of where you would use inverse trig. All right, we have one last problem. This one's a little trickier. It says a toad is sitting in a hole with his mouth 3 inches below the surface. Let's draw that. Here's the hole. His mouth is 3 inches. Here's your little toad. Great toad. His mouth is going to be 3 inches below. It says he spots a fly at an angle of elevation of 40 degrees. Horizontal line, line of sight, 40 degrees. It says angle of elevation of 40 degrees. The fly is 5 feet or 5 inches above the ground. That part is 5 inches. How long would the frog's tongue need to be to stretch to get the fly? Well, this is going to be the length of his tongue. Now the only thing here is the 5 is not the total length of that side. You got to remember that this part right here is 3. So if I had to just draw a generic triangle, we're solving for that. Over here is 8, and this is 40 degrees. At this point, you have to figure out what sides you're working with. Looks like opposite and hypotenuse. If you look at SOHCAHTOA, opposite and hypotenuse is sine. So sine of 40 degrees equals opposite over hypotenuse. multiply by whatever's in the denominator. In this case, we have to do 2 steps to solve. 8 divided by sine of 40. 8 divided by second sine of 40, and that gives you 12.44, which is 12.4 inches. All right, the most important thing that I have to remind you guys of is number one, if you're looking at an angle of depression, make sure that it is between the horizontal line and the line of sight. Here, not here. Making a big deal because every year the kids have issues with it. And then number two would be careful with eye height. If there's a man looking up at something with an angle of elevation, a lot of times he is going to have an eye height that you have to account in because the triangle is technically floating in the air and you still have to figure out what the total height is of the object, and that would incorporate having to add in your eye height. All right, thanks for watching.